type is in the chat box. So, yeah. So, very good evening all. In the previous class, we were discussing on the hands-on problems related to battery. We were more parameters related problems related to the lithium iron phosphate cell, right? And we have seen how to calculate different parameters like SOC, higher cutoff, lower cutoff, and so on. And then we have done a couple of problems to understand SOC. Then we understood different configurations of cell. And today it's a very interesting session that we try to make a battery pack and we'll try to interface with BMS. And we'll see how to choose BMS first of all. And once we finalize what BMS we have to go for, then we'll go to the consumer website and we'll try to select a BMS. And then we'll do wiring for the BMS with the battery pack. And then we'll see what are the different parameters that BMS is going to monitor and how those sensing happens. Okay, so this is the focus for today's class. So before that, I would like to ask some questions related to the problems which we have studied in the last class, so that to check whether you remember the concepts or not. So can anyone tell me what is the nominal voltage for lithium iron phosphate cell, LFP cell? What is the nominal voltage value for lithium phosphate cell? There are different answers. You should give the same answer because we have given the class, we have done the class in the previous week. So I'd like to see a common answer. Okay, so the answer is 3.2 volt. Very good, 3.2 volt. What is the upper voltage cutoff? What is the upper voltage cutoff for lithium phosphate cell? Very good. So it is 3.65 volt. Very good. What is the lower voltage cutoff? Very good. So it is going to be 2.5 volts. Assume that if I have 3.2 volt 6Ah cell, a 3C cell, what is the maximum discharge current from the cell? 3.2 volt 6Ah 3C cell. What is the maximum discharge current from the cell? It is, I'll repeat, 3.2 volt 6Ah 3C cell. So what is the maximum discharge current from the cell? Yeah, it is not 18 Ah, it is 18 ampere. Okay, 18 ampere in some hours, let's say 0.2 hours or 0.3 hours or 0.4 hours, let's say. So the answer should be 18 amperes. If suppose, let's say I have a 3.2 volt 6Ah, right now inside the battery I have 4Ah. I'll repeat, I bought a cell 3.2 volt 6Ah, but currently I have only 4Ah inside the cell. What is the SOC of the cell? In percentage. I bought a 3.2 volt 6Ah cell. Currently the cell has 4Ah inside. So how do you find it? I have 6Ah pack, 6Ah pack, but I have only 4Ah inside. Okay, so the SOC will be 4Ah divided by 6Ah, which is 66.66%. Very good. What is the depth of discharge? I have 3.2 volt 6Ah. Currently the battery has 4Ah. What is the depth of discharge happened? 33.33%. Very good. How do you find the charging rate of the cell? Suppose the cell which I bought is 3.2 volt and 6Ah. Okay, 3.2 and 6. And I would like to know what is the charging SOC, charging H or C, charging rate. 3.2 volt 6H, charging C rate. To find the charging C rate. Discharging C rate normally, which is written on the cell, let's say if it is 3 Siemens, then as you said, it is 18 ampere. But for charging, how do you do it? Anyone? Okay. See, I bought a 3.2 volt 6H cell, which is a 3C cell. I would like to know at what rate or how much current I should send for charging. For discharging, I know it is 18 amperes, 3 into 6, which is 18 ampere. So I can understand that 18 ampere I can take from the cell. But my question is how much current we can give to the cell and charge it. What is the charging current? It is not upon the input voltage. The input voltage is, let's say I have a source, voltage source, which can give you 200 ampere of current. Will you send the 200 ampere of current to the cell? No, it should not depend upon the supply. Okay. It should depend upon the battery only, cell, the capability of the cell. That's what we were talking in the last class. When you take your EV battery to a charging station, it is not the charging station decides what amount of current should flow to the battery. It is the battery should decide what amount of current it can accept. Although the charger may be designed for 200 amps, 300 amps, or 500 amps, but it is the capability of the battery that decides how much current flows inside the battery. So that answer is you have to check the data sheet. Okay, you have to check the data sheet and see what is the charging C rate. We have seen a sample data sheet in the previous class. So there they mentioned 0.5 C for that particular cell. Okay, that particular cell it was 0.5 C. Or some data sheet will tell 1 C, but anyhow, the charging C rate will not be seen on the cell sticker. Okay, that you have to refer only the data sheet. Suppose your data sheet is not giving that data, what is the charging C rate? Then the thumb rule we follow is 0.2 C to 0.5 C. Okay, so that is the charging rate we follow as thumb rule. If suppose the charging rate is not defined anywhere in the data sheet, or the supplier is failed to give you the data sheet. Okay, so these are the things which we have seen in the previous class. And today we would like to go for BMS. We are trying to interface a battery pack with the BMS. So before interfacing the BMS, I would like to ask you to draw different configuration. Hope you remember we have drawn different configuration of 4s2p, right? 8s2p, right? 8s2p. Okay, so let's say 15s4p. So can everyone try to draw this configuration in a paper? 4s2p configuration, 8s2p configuration, 15s4p configuration. Okay, so you have to this is the battery pack configuration. Okay, you have to develop this battery pack for this configuration 4s2p using the cell 3.2 volt 6H. Okay, so I'll give you 3.2 volt 6H cell, and you need to build a battery pack using this cell 3.2 volt 6H for 4s2p configuration, 8s2p configuration, and 15s4p configuration. Okay, so please draw it. I'll pick some people randomly and I'll ask you to share the screen. Okay, so I'll give you 5 minutes time to make this configuration, to draw in a white paper or your notebook. So please do it for 4s2p, 8s2p, 15s4p. Once you are completed, please type completed in the chat box, so that I'll give you access to share your answer. First one is 12.8. Okay, 12.8 volt and 12H. If what is the answer for the second one? $25.6 volt. Okay. Okay. Also, please draw, everyone. Please draw. If you don't draw it, you will not understand. When you try to make a battery pack, you will get confused. So this, as you said, 12.8 volt, 12.8 volt, 12H, 12H, and this is 25.6 volt, 25.6 volt, 12H, and this is third one, 48, yeah, 24H. And can somebody say what kind of charger you will choose? What is the charger voltage for 4S2P? What is the charger voltage? I mean, charger maximum voltage means open circuit voltage. What is the charger voltage for 12.8? Discussed in the previous class. Hope you remember the logic to choose the charger. In the first case, how do you, what is the formula to find for the first case? Don't tell that 12.9 and above. You tell me what is the maximum voltage. That's it. How do you find it? So if somebody is asking you to figure out an appropriate charger for this particular 4S2P configuration, right? So you should tell a convincing way to choose the charger. We know very well if you give 12.9 also it will charge. If you give 13 volt also it will charge. But that is not the question here, right? How do you find? Yeah. So we know that what is the higher cutoff of single cell? What is the higher cutoff of single cell? 3.65. Right. So 3.65 into 4 because 4 is, so 4 into 3.65 will be 14.6 volt, right? So the charger maximum voltage will be 14.6 volt. Okay, so you have to choose the charger voltage in and around that 14.6 or 14.8 or 15 volt, something like that. So mostly market will have 14.6 open circuit voltage of the charger. For 8S2P, how do you choose? Is the charger voltage 8 into 3.65, right? Very good, 29.2 volt. So 29.2 volt is the charger voltage. Okay. So what is for 15S? For 15S configuration, 54.75. 54.75. Okay. Now assume that the charger, as I said, the charging current rating is 0.5 C. The charging current rate is 0.5 C. If so, okay, if so, what is the charger maximum current? What is the charger maximum current? 4S2P. The maximum charger current. Going to choose 0.5 C. Very good. It is going to be 0.5 into C. What is the C rating? The C rating is it is 6H, totally 12H, correct? So 0.5 into 12. So 0.5 into 12 is 6 amps. So I'll be choosing 6 amps charger. 14.6 volt, 6 amps charger. And for this case, 8S2P, again we have 12H. So we go for 0.5 C. It's the same answer, 6 amps. I'll choose a 6 amp charger. Okay. 15S4P. So we have 24H totally. So we'll go with a 12 amp charger. Okay, 12 amp charger. Okay, so this is how you'll be choosing the charger rating. Okay, the charger rating for 4S2P, this particular configuration, it is 14.6 volt and 6 amps. For 8S2P, it is 29.2 volt and 6 amps. And 15S4P, it is 54.75 and 12 amp. Okay, let us see in the market. I'll just try to see whether 8S2P charger for this particular rating, 29.2 volt to 6 amps in the market. Let me try to search and find out a charger, whether our answer relates to a practical answer or not. So if you try to browse LFP 8S charger 6 amps. Okay, so you can see 29.2 volt to 6 amp LiFePO4 charger. Okay, this is for 8S. Okay, so you have the practical charger rate in the market also. Okay, so this is how we find. Okay, so you can see 14.6 volt charger. So 14.6 volt charger is suitable for which configuration? You can see it is for 4S configuration. Okay, so the answer is not theoretical answer. The answer is the practical way to figure out the charger voltage and charger current. Okay, right. So now we try to draw 4S2P configuration. Okay, so tell me how should I draw 4S2P configuration? Anyone? Just help me. What should I do in order to make a 4S2P configuration of battery? 4S2P. How should I draw it? Totally tell me how many cells will come. How many cells will be in series? How many cells in parallel? Total number of cells. How many cells in series? How many cells in parallel? 4 in series. Okay, somebody says 8. You read this 4S2P. How do you say 4S means 4 cells in series? Okay, so this one I'll interpret like this: 4 cells in series. How do you interpret? How do you interpret? Not 2 cells, right? Not 2 cells. 2. Okay, such. Okay, such means this one. 2 such parallel 6 means what? First I will draw 4 cells in series. Okay, 4 cells in series. So this is what? 4 cells in series. Okay, so I have drawn 4 cells in series. So how do you connect series? First cell, this is plus, minus. Minus of the first cell will be connected to the second cell plus. Minus of the second cell to the plus of the third cell. Minus of the third cell to plus of the fourth cell. Right? So if you look at a minus will come on the bottom. Right? A minus will come on the bottom. A plus will come on the top. So we call this as battery plus, B plus. Okay, battery positive. Okay, and this is battery B negative. Okay, B minus or negative. So when I see the battery voltage, I'll get only 2 wires. One is this is the positive wire or called red wire. Okay, and this is the black wire. This is the black wire. These connections, how do you make these connections? One cell to another cell, this series connection. How to make the series connection? So this we do through the nickel plating, right? So we do the spot welding. I'll show you the picture after break. I'll try to get some pictures. Okay, so the real battery pack pictures, so that you will be able to relate it. So these are the spot welded using the nickel strip will spot weld inside. You cannot see it outside. Only you'll get 2 wires. One wire is this wire. Battery plus will come outside. Battery minus will come outside. Only 2 wires will come outside. Right? Okay, so this is 4 cells in series. Now 2 such means what? Already we have 4 cells in series, right? 2 such strings. So that means I have to draw one more string, one more same 4s. One more same 4s. Okay, and its negative is connected to the common negative, and its positive is connected to the common positive. Okay, and these are spot welded again. This is spot welded, this is spot welded, and this is spot welded. Okay, let me put another color so that you will. This is red. Okay, and I'll put black. So this is the negative, and this is also negative. So both are common to form B negative. B negative. So this is 4S2P configuration. 2 4S parallel strings. One 4S is parallel to another 4S. So totally 2 such parallel strings. Okay. Anyone? Any doubt in this? Anyone any doubt? Redraw it clearly. So all have done the same way. Okay, okay, great. So this is the battery plus and this is the battery minus. B minus. Right. So what is B plus to B minus voltage? From here to here, what is the voltage? The voltage. So when we make the battery pack, what is the voltage of each cell? During the process of making, while you're making the battery pack, what will be the voltage of each cell? You charge the cell completely and make the battery pack? Or do you discharge the cell completely and make the battery pack? What will be the voltage of the cell? Yeah, very good. So normally we maintain all the cell voltage to be equal to nominal voltage of the cell, okay, during the process of making the battery pack. Okay, so assume that all the cells will have the same voltage, 3.2 volt. So this is 3.2, 3.2, 3.2, 3.2, 3.2, 3.2, 3.2, 3.2. Okay, so when I measure from B plus to B minus, how much will be the voltage? Each cell is 3.2, but I'm going to measure from B plus to B minus. So I should get 12.8. Right, 12.8. Now if the one cell is, see, we don't do it, Mishra. While making, see, it is not like you buy 100 cells and you take any 8 cells and make the battery pack. It is not so. We do a process called sorting and grading, okay? And we ensure that all the cells, let's say out of 100 cells, we'll try to see which of the cells are very close to their internal resistance and very close to their nominal voltage. So for example, one cell will be 3.219, another cell will be 3.119. I'll write it here. One cell is 3.2119, another cell is 3.119, let's say 119, another cell is 3.2117. Okay, so in this case, I'll try to group 3.2117 to 3.2119. Okay, if suppose I have another cell 3.2116, I'll try to group it. If suppose I have 3.21 or 2, I'll group it. Okay, so I'll try to group the cell which are very close to the voltage and which are very close to their internal resistance value also. Okay, typically the internal resistance will be 4 ohms to 4 milliohms to 8 milliohms. So we'll check the internal resistance using IR meter and then we will group it. So out of 100 cell, I'll test all the 100 cell, I'll check all the 100 cell and I'll sort it and grade it and use the more identical cells while making the battery pack. So there is no question of having one cell as 1.9 volt, okay, or one cell as 3.1 volt. There's no question. Is it clear? Okay. So now the aim is to interface BMS, but before that, everyone has a doubt. The doubt is that, sir, how do I measure it as 12.8 volt? So currently you can tell, you will add 3.2 plus 3.2 plus 3.2 plus 3.2, you will get 12.8. But if there is a voltage coming from B plus to B minus as 12.8 volt, how do you measure it? So what circuitry you will design and what is the logic you use, okay, so that you'll be able to measure the voltage 12.8 volt. So this is the task which we are going to do right now. Anyone? Suppose if your battery is 12 volt, you'll be using a multimeter and say that, sir, it is 12 volt. That is fine. But when it is inside a circuitry, we are not going to use a multimeter. As a circuitry, how it sense that battery voltage is 12 volt. Okay, as an engineer, we are going to understand how do we sense voltage. Okay. So anyone, any idea? Using ADC. So to understand that, I'll do